All right, so today, in fact, we are going to be going through Geography Unit 1, 2008, question number 1, the map reading question. All right. If you are required the maps, you can simply email me, all right, and I will simply send you the PDF copy. All right, it has the resolution scans. Let's go through quickly. All right, so we are in fact dealing with a map extract of Nevis, right? The first part of the question basically is focused upon Nevis, right? The map of Nevis, which is at a scale of 1 to 25,000. Now, before, always remember, right? Always take approximately 2 minutes to peruse the entirety of the map. Okay. All right. So this is in fact the map of Nevis here. All right. As you can see, there are in fact certain color codes. There are in fact certain contours. You can simply see the contours and whatnot. All right. We can simply zoom in on the map, and you can eventually peruse, right, the entirety of this particular map and look at the key. Right. Pay very close attention to the key, which is extremely important. All right. Keep that in mind for me. I want you to look at road networks. I want you also to look at the actual color codes. I want you to look at the places, look at the coastal environments, look at the settlements, look at every single thing. Look at the water courses as well. All right. Look at the symbols. All right. Pay attention to the important symbols as you would have basically, if you look at the key, all right, you will see some of these symbols as well. So take a couple minutes and look at this particular map for me, please. You can actually pause the video if you wish, all right, while you are perusing your map separately. All right, so the first part of this question is to describe 4 characteristics of the settlement pattern of the map extract. 4 characteristics of the settlement pattern of the map extract for 8 marks. Let's go through this very quickly. All right, now given the fact that we are seeing on your screen here, all right, I want you to pay attention to the small little dots. For example, these little areas in the corner here, these little dots and whatnot. You realize that before we jump to the question, let us realize that the actual map itself, we are seeing the central region is in fact very, 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 very steep. As a matter of fact, this is what you call Nevis Point. All right, Nevis Point, which is situated in the center, and it emanates further out. All right, keep that in mind for me, please. Now, if you were to look carefully on the map itself, you will realize there are in fact a lot more settlement patterns concentrated along the coastal region. All right, throughout the entirety of the map, that is basically on the gentler slopes, or I should say on the undulating region of the landmass itself. All right, basically away from the central elevated peak. Okay, so roughly settlement patterns are in fact concentrated in the coastal region. All right, primarily because of the fact that there is in fact gentler topography, which is quite contrary to what exists, right, in the central part of Nevis. So that is actually the main reason. Now, secondly, I want you to also remember that there are in fact linear settlement patterns. There are in fact numerous linear settlement patterns throughout the screen. I'm sorry for the little sticking error issue here with the map. Apparently, getting a little glitch. There are in fact a lot of linear settlement patterns throughout the map. All right, as you can see along the main roads. All right, this red line is indicative of a primary road or a main road. All right, if you look at the key, you will actually see it. Now, the area is largely associated with linear settlement patterns, but throughout the general part of the map, right, where these roads and whatnot exist. All right. Now that is actually significant because these roads are in fact very significant transport routes. And that being said, linear settlement patterns, and there are in fact certain areas where dispersed settlement patterns may exist, but it is mainly linear. All right. These settlement patterns are in fact mainly linear, with the exception of the fact that on Charlestown, which is in fact the western fringe of the map, all right, you realize that that area is said to be largely nucleated. All right. Okay. Now, this little green section that you are seeing on the screen, where you've realized that the majority, like a very large majority of the settlement patterns exist, right? That is in fact associated with cultivation. If you would look in the screen, you will actually see that cultivation and plantation. And that is actually something very significant. Settlement patterns are in relatively close proximity to cultivated areas and plantation areas. And this is in fact something unique, and not really unique, but something very significant as well, because cultivation and plantation would reap rewards, which would in fact be utilized primarily by the persons, or the population in the particular region. All right, so keep that in mind for me, please. That is a major primary economic activity and also a major derivative of food. Okay, so cultivated areas are largely associated with these settlement patterns, which is either nucleated or linear, or in some instances dispersed. All right, for example, Charlestown here is largely nucleated, but look at the proximity to Clark's Estate. All right, look at all these linear settlement patterns here at St. Paul's, Charlestown, as well as St. George, Gingerland. You realize that they are, in fact, these areas are concentrated within the cultivated areas. All right, keep that in mind for me, please. Our next thing to the fourth point is that settlement patterns are in relatively close proximity to road networks. All right, as you can see, wherever there are roads, that actually is in fact a unique region where you will actually have settlement patterns being much more concentrated there, primarily because it provides a means of access, right, from one distant area to another throughout the entirety of the island, especially all right, along the coastal regions or certain areas inland, for example, St. Paul's, Charlestown, and St. George, Gingerland, right? But the majority of the settlement patterns are largely coastal. All right, so keep that in mind for me, please. Okay, and it deviates from the central Nevis Peak. Okay. The second part of the question basically asks us to describe the location of Charlestown and suggest 3 reasons for the importance of its location. All right, we have to describe the location of Charlestown's first. You remember that, all right? Then you have to indicate the reasons of for the importance of the location. Let's go through this quickly. All right, so looking at the Zoom version here, Charlestown basically is situated on the west central part of Trinidad, and we know for sure Charlestown is situated on the leeward or sheltered part of the region. All right, and why would I say this? Remember, Caribbean islands experience northeast trade winds. This is on the leeward side, which is away from the windward side, of course. And we know for sure this area is relatively sheltered. It is actually in an area where there are, in fact, also coral formations on the outer fringes here. All right, that will also provide some level of a sheltered effect as a natural breakwater as well. So the area here is relatively calm. A nice little justification of this is that, as you can see, there's a jetty here. All right. And this jetty, the area is in fact found in a natural harbor. Okay. We know obviously the area is said to be very much nucleated in terms of settlement development. All right. Anyway, so with respect to the reasons for the importance of Charlestown, we must bear in mind that there are in fact multiple interconnected road networks here, right, which can actually access in almost every direction from the specific town. All right. Secondly, we must bear in mind that Charlestown is situated on relatively gently undulating land. As you can see, the contours here are relatively spaced out, and you are moving closer to the coast. In addition to that, another clue. If you look in the key, this little area here that you are seeing dots, look in the key when you get your map. All right, you can simply see that that is also associated with sand deposition. Once you have deposition associated with a particular area, the landmass is said to be relatively calm and also it will actually be relatively stable. All right, so gentle topography is in fact associated. So far, we understand the road networks, right? The numerous road networks, interconnected road networks, and also we understand the fact that there are, in fact, gentle topography. There is, in fact, gentle topography. All right, and we will also highlight the fact that Charlestown is situated in a sheltered region, specifically on the leeward part of the island. Why would we say sheltered? Because we mentioned earlier that this particular region on the in the coastal region and outer, we will see coral structures and also sand deposition on the fringes of the coast. In addition to which, as we mentioned earlier, it is also situated in the leeward part of the island. All right, so Charlestown, just to reiterate, is in fact a unique location which harbors the largest density or the greatest density than any other part of the island itself. Keep that in mind for me, please. All right, question B, part 1. With the aid of a sketch map, describe the relief of the area, which is north of Northing 97 on the map extract for 9 marks. You will be given marks for the sketch, and you will also be given marks for the relief. The relief refers to the topography or the slope angle of the land. We are looking north of Northing 97. All right, so look carefully. Northing 97 is actually at the base here, and you are looking north of that. All right. Remember, northings are horizontal lines, and look carefully on the map. Look carefully from what we can actually see here. Pay attention. I want you to observe almost every single detail at this particular point. Now I'm going to do a very simple sketch map here for you, all right? This region here is actually the northern fringes of the landmass which emanates from Nevis Peak, right? Which is at St. Thomas Lowland or whatever, which actually is the lower reaches of the landmass itself. But there are in fact certain elevated areas, right? Typically referring to this region here in the periphery of St. James Windward, as well as Round Hill, which has a trigonometric station of 1014, that is meters above sea level. And we also have a very distinctive factor here, which is also something very significant, which is in fact Hurricane Hill, as you can see from your screen. All right, I'm going to zoom in a little bit so you'll see it properly. All right, Round Hill and Hurricane Hill. So I'm going to sketch my map quickly. Right, so don't mind my little weird diagram here, right? So this basically, these green areas are what we call the cultivated areas. And we know for sure, based upon what we would have seen from the map, that the majority of the cultivated areas are in fact encompassed largely by settlement patterns. All right. We also have the very elevated areas. For example, this region here is in fact associated with the peaks, the landmasses, which descend from the original Nevis Peak, which is further down south. All right, and it emanates throughout. So this is like a rough understanding. We have here is Hurricane Hill, and we also have Round Hill here, where there is a trigonometric station. All right, this can also be included in your key if you wish. All right, so you could also include the trigonometric station. I believe that's in a blue color. Trig station. All right, I apologize about the handwriting, y'all. Anyways, so we have this here, right? Let us discuss this quickly. Oh, by the way, remember it would be very, very counterproductive to actually draw the individual contours, because that would be too time consuming and that would be very, well, virtually impossible. All right, because remember it's a sketch. Remember, if it is a sketch, it is not drawn to scale. All right, keep that in mind for me, please. It is not drawn to scale. All right, let's go through quickly. Right, so looking back at the original map, we can actually see in the central region, we have very, very steep slopes, which actually, well, as it moves progressively towards the direction of the coast, it becomes gentler, with the exception of certain areas. For example, we also have St. James Windward, which is also a relatively steep area as well. As you can see, the contours are in fact relatively steep and very close by. We also have Round Hill, which there is a trigonometric station, which is also very, very steep, as well as Hurricane Hill. I took a liberty of mentioning that in the diagram as well. So Hurricane Hill, which is situated in the northern fringes of the map, as well as the further inland area, which is in fact Round Hill, is in fact very, very steep, and settlement patterns there are in fact, non-existent. All right. The relief there is in fact very steep, as a matter of fact, in comparison to the other peripheral regions. Also, if you were to look carefully at this particular region here as well, which is further to the south, which is on the left-hand side of St. Thomas Lowland, which is in fact the reaches of the land masses which emanate from the original Nevis Peak, we must bear in mind that that area is relatively steep as well. Good. So as you move further to the coastal fringes, you realize that the topography lessens. It becomes less elevated. It becomes gentler, as a matter of fact. All right, let's go back to the actual sketch. All right, so we can see here we have Rounded Hill understood, with the trigonometric station here at 1,040 meters above sea level. We also have Hurricane Hill, which is right here on this end. Hurricane Inn, I'm sorry, my bad. And we also have St. James Windward, right, which is situated in this region here, very close to the descending peaks from Nevis Point. Now, this is in fact in Northing 97, all right? But we know further below that, the central Nevis Point exists. However, this region here is in fact the region where the slopes, as it moves further emanates further towards the coast, we realize these are in fact the descending slopes of Nevis Point, which become increasingly gentler, but it is still relatively steep. All right, so we know for sure these are descending points, all right, of Nevis Peak. All right, that being said, also bear in mind that these cultivated areas are associated with gentler slopes. All right. The areas in green are associated with gentler slopes, and those are in fact the areas which harbor a greater degree of settlements. Okay, keep that in mind for me, please. You'll be given marks for labeling. Try to label as quick as possible. Don't spend too much time on this. As a matter of fact, you have a lot more other questions to do in the exam. But at the same time, it's just a sketch. All right, use your scale if you have. No, sorry, use your key and not drawn to scale. Keep that in mind for me. All right, moving quickly into the second part of the question. Compare the river valleys. All right, compare the river valleys of Fountain Gut with that of Camp River. Now, Fountain Gut is 4099 to 3997, and Camp River is in fact 3801 to 3987. Let's go through quickly. All right, now if you look carefully, this is where you have to search the map, right? If you look carefully, you'll realize Camp River, all right, is situated in the north, this northern region here. You'll see my cursor. All right, this northern region here. And you realize it actually originates further inland, all right? It originates further inland at the base of Nevis Peak, right? Averaging an estimated, averaging at an estimated 1,200 meters above sea level. That is the point of origin, the source of Camp River, all right? And it flows basically, all right, in a northerly direction, all right, where it drains in a northerly direction out to the sea, all right, passing through, in close proximity rather, to Beachland Estate. All right, now let us look at Fountain Gut. Now, Fountain Gut basically is this particular river here, all right? Fountain Gut, this region right here, is in fact emanating, right, also at the base of Nevis, roughly at the base of Nevis Point, at an estimated 1,100 meters above sea level. If you look at the contours, you will see it. And basically, it flows in a specific directional pathway towards Hicks Estate, all right, and eventually drains in a northeasterly direction out towards the sea. Now, if you have to compare the valleys, all right, I want you to bear in mind that Fountain Gut is basically associated with steeper slopes. The valley sides where the actual river itself flows, all right, that is in fact associated with steeper slopes. These valleys associated with Fountain Gut is said to be narrower, all right, given the closeness of these contours. It is said to be much narrower, all right, in comparison to that of Camp River. If you look at the contours for Camp River at the point of origin, you realize that the contours are in fact a little further apart in comparison to Fountain Gut. The origins of Camp River, which is right here, is a bit further apart than the origins of Fountain Gut, which is further upslope. All right, and we know for sure Fountain Gut is associated with steeper terrain in comparison to that of the river, Camp River. All right, and we know for sure the valley itself at Camp River would in fact be slightly broader, all right, but at the same time it would not be as steep. All right, the slopes would not be as steep as that of Fountain Gut. Why? Because of the differences in terms of the closeness of the contours. Fountain Gut, you have closer contours. Camp River, you actually have contours which are still relatively steep, but they are in fact further apart. Just to reiterate quickly, Camp River flows in a northerly direction. It drains in a northerly direction towards the sea, whereas Fountain Gut drains in a northeasterly direction towards the sea. All right, keep that in mind for me, please. Now, part C is based upon this particular image here, all right? It's a photograph depicting some consequences of severe flooding in the Caribbean territories caused by Hurricane Ivan in 2004. All right, if those of you remember, Hurricane Ivan was in fact a very destructive hurricane which simply ravaged large sections of Florida as well as the Caribbean. Now, I want you to take approximately a few minutes. I want you to look carefully at this particular image here. All right, let's go through. Pause the video if you have to. All right, so the first part of the question is identify 3 types of physical damage evident in Figure 1. All right, so from Figure 1, we can automatically see, if you look at the corner on the left-hand side of the actual image, you can see there's a fallen building. All right, so you can see damage to buildings. All right, also, there's an area here where there's a bridge. This bridge would have actually sustained damages, right? So damage to bridges, or in this case, you can see bridge. And this water course, which is below the bridge, is in fact largely subjected to a lot of sediments accumulating here. So that is associated also with blockage of water courses. And bear in mind also, these little rocks and rubble, they may not necessarily be only associated with rubble coming from the top of the mountain, but it can also be associated with what? Debris from bombarding objects coming into contact with man-made structures. All right. If you look at the region, we can see of course, there is a lot of infrastructure work that is to be done, right, in an attempt to remediate the efforts here. All right, let's go through. Remediate the effects, sorry. All right, now the second part of the question, we have to outline two different environmental risks associated with severe flooding. Now, two different environmental risks associated with flooding, based upon the image that we looked at, there's also a clue in the image, right? I will tell you that we would have seen that there is, in fact, blockage of existing watercourses. Now, blockage of existing watercourses can severely have an effect upon a region. Why? Because if the watercourses are in fact blocked, that means there will be a less efficient flow of water from the region, from the land, which will technically saturate the ground, and the areas where settlements exist would in fact be greatly compromised, because water, although it takes a relatively long period of time, it will gradually destroy the foundations of buildings, especially if water settles and it does not expeditiously drain out. So blockage of watercourses is in fact a very significant problem. Can compromise the building's structural integrity. Secondly, let us talk about, apart from that, we can actually see that flooding, all right, apart from the fact that sediments are actually brought downriver, we can also consider the fact that flooding, given the volume of water and also the flow velocity of the water, all right, which is if both of them are very high, that can contribute to a significant degree of erosion. All right. Although sediments accumulate at the base of the slopes, we must understand that the upslope areas are in fact subject to great degree of erosion. All right, and that is because of the volume of water in relation to the flow velocity of that particular body of water as well. All right. Last question for the entire paper. We have to suggest 4 measures that can be employed to mitigate or to reduce the severity of the effects of the hazards depicted in Figure 1. Let's go back into the actual image. Now, 4 measures that actually be used to mitigate the effects of the hazard here, which is in fact flooding. We must bear in mind that first and foremost, this watercourse needs to be properly dredged. Right, there must be dredging of watercourses, and this actually should be done prior to the wet season, right? Depending upon the kind of climatic condition we experience. Dredging of watercourses actually remove obstacles and debris and materials which can actually hinder the expeditious flow of water. All right, if they are not properly dredged and the watercourses are in fact blocked, this can contribute to a backing up or a ripple effect, whereby water tends to remain on the ground in further areas, inland areas that is. Now, secondly, I would like to focus on the zoning regulations and land use planning. Now, this is actually something very important, especially when you talk about the relocation efforts. Now, if you have to remediate the effects, those persons who were in fact compromised, their structural integrities were in fact compromised, we must understand zoning regulations will be a very important parameter. Why? Areas can actually be demarcated for proper infrastructural development, and land use planning will actually have a more accountable approach in terms of development. All right, so those persons who have to be removed from this particular floodplain environment, they should be relocated elsewhere, and this can actually minimize the risk of experienced floods again. All right, because you don't want to be in the exact same location where annually, perhaps seasonally, or even perennially you experience floods. So zoning regulation is in fact a very significant tool, mechanism, and action, all right, and also land use planning as well. Thirdly, reforestation projects. I want you to look carefully at the image on the screen here. Look at the upslope areas. You've seen there, it's fact certain areas which appears to be very scanty, or these areas were perhaps subjected to deforestation and logging, or at some point some level of clearance, all right, as it could be influenced by fires or whatever, we don't know. All right, but the fact of the matter is that deforestation is a problem. So reforestation projects involves the planting of trees in areas where trees previously existed. And why is that important? Reforestation is extremely important, as we would have discussed in a previous module. In this particular unit, reforestation or vegetative cover contributes to a greater degree of foliage. And this foliage will actually contribute also to a greater degree of infiltration, reduce the impact of raindrops, and by extension, will contribute to a greater degree of interception as well. Both infiltration and interception will increase with increase in vegetative cover. And this can actually reduce the very quick output of water into the main channels. So the water in the main channels would not rise very quickly. The water will actually be held atop of leaves of trees on their foliage, that is, all right, gradually descending and allowing the water from a channel to be drained, right, out of the particular region or area. All right. Infiltration. Remember when we spoke about in class that infiltration rates when they are low, overland flow is high. Overland flow is indicative of floods. So if you increase the rates of infiltration by applying some buffer, which is vegetative cover and foliage of trees, right, which is influenced by reforestation projects, this can actually contribute to a positive impact where interception and infiltration rates can increase. Now, the last point, there can in fact be the establishment of floodgates, right, or even levees, man-made levees, which are in fact elevated riverbanks, can be basically developed or perhaps maintained, all right, and in doing so, this can actually control the amount of water that is actually present on the land. This can actually regulate the volume of water from any given area, and it is in fact an infrastructural approach. Okay, so this can actually be very significant as well. Okay, so I hope this is actually beneficial to your class. This isn't the entirety of question number 1 from Unit 1 paper, right? Geography, map question, 2008. All right, students, any questions, feel free to email me or let me know.